Periodic Properties 1. In this video, we will discuss the periodic properties, atomic radius, and ionic radius. The definition of atomic radius is the radius of an atom. This may sound simple, but in practice it is not so easy to measure. This is mainly because the atom does not have a definite boundary, and so it's hard to find the edges of a single atom. However, we can locate the nucleus of an atom fairly easily. So if we bring two atoms together, measuring the distance between the nuclei is fairly easily done. The radius of the atom is then half the distance between the nuclei. On this diagram, we can see how this works. We measure the distance d and divide by 2. You can see that the diagram calls this the bonding atomic radius, which hints at some potential differences if atoms are not bonded, whatever that means. This bonding atomic radius is what we call the atomic radius. Shown is a diagram which shows the atomic radii as the heights of the element boxes in the periodic table. You will note that, although the change is far from perfectly in line, the heights of the boxes, and therefore the atomic radii of the atoms, tend to increase as we move from right to left across a row in the periodic table. There is a reason for this change. As we go from left to right across a row, the atomic number increases, and therefore the number of protons in the nucleus increases. The outermost electrons, the valence electrons, are in the same shell for all the atoms in a row, but are attracted by more and more protons, and so are pulled closer to the nucleus as the number of protons increases. This makes the atom smaller. And the radius tends to increase as we go from the top of a column to the bottom. As we come down a column, the valence electrons are in higher energy shells, which are further from the nucleus, so the atom gets larger. There are lots of exceptions to this general pattern, some of which are related to the issue we have mentioned earlier of the bonding atomic radius, and others of which are real exceptions to the pattern. There is not a nice relationship among these exceptions, so we will ignore them. Ionic radius. The definition of ionic radius is similar to the definition for atomic radius. The ion is produced either by adding one or more electrons to a neutral atom to form a negative ion or anion, or by removing one or more electrons from a neutral atom to make a positive ion or cation. Because ions have no clear boundary either, you might expect that there are similar problems in determining the ionic radius to what we have in determining the atomic radius, and you would be right. In addition, we cannot bring two positive ions or two negative ions together, because the ions repel each other, so that there is the additional problem in determining the ionic radius that we must have ions of different charges near each other to measure the distance between the ions. Let's look at the two types of ions separately and compare each to the neutral atom. When we make a positive ion, we remove one or more electrons from the neutral atom. Most frequently, when we make a positive ion, we leave the valence shell empty. This leaves us with fewer electrons that are closer to the nucleus than the valence electrons that give us the atomic radius. This means that the positive ion will be smaller than the neutral atom. When we make a negative ion, the neutral atom gains one or more electrons. The additional electrons generally fill the valence shell of the atom, so there are more electrons in the valence shell of the anion than in the valence shell of the neutral atom. Because there are more electrons in the same space, the electrons in the valence shell repel each other more than they do in the neutral atom, so the electrons move further apart. So the negative ion would be larger than the neutral atom. Is there anything we can say about the general trend in ionic radii? Actually, there is. In a particular column, the ions tend to be of the same type and have the same charge. As we go down a column, the ions tend to get larger, just as the atoms tend to get larger. Going across a period, the ions tend to get larger going from right to left. However, there is a warning to be made in relation to this trend. At some point in the row, we will change from negative ions on the right to positive ions on the left. When we do this, we change from ions that are larger than the neutral atoms to ions that are smaller than the neutral atom. This usually happens around group 15 or 16. When this happens, there will be a significant decrease in the size of the ion. So, these general trends, with the warning about comparing cations to anions, are the same as the general trends for atomic radius. Both the atomic radius and the ionic radius tend to increase to the left across a row and increase going down a column.